Hello everyone, in this video we'll be solving problem 215, kth largest element in an array. The problem statement is, we are given an integer array nums and an integer k. We need to return the kth largest element in the array. Please note that it is the kth largest element in the sorted order and not the distinct element. And as an added challenge, we need to solve this problem without having to sort the input. In example number 1, with these as our input and k is set to 2, the second largest element in the input nums is 5. In example number 2, where k is equals to 4, amongst all of the numbers given to us, 4 is the fourth largest number in the input array. Even though we have the same number 5 appearing twice, they both are considered separate numbers. Hence, the fourth largest number in the array is 4. I hope you are able to understand the problem statement. Let's start solving this problem with the most basic and easiest approach, that is sorting the input and then trying to figure out the kth largest element. Once the input array is sorted, we can simply run the iteration from right to left to figure out the kth largest element. We can also mathematically calculate the index of the kth largest element based on the length of the input array. In this solution, as we are running a sorting algorithm, the time complexity will be n log n, and then we are running a loop to identify the kth largest, whose time complexity will be O of k. So combining the two together will give us O of n log n as the final time complexity. And the space complexity is going to be O of 1, as we are not creating any additional variable for the calculation. We are simply sorting the input array directly and then running a loop to identify the kth position. Hence the space complexity is O of 1, that is constant space. Now let's discuss a different approach where we can adhere to the requirement of not sorting the input array. Because we need to calculate the kth largest element from the input array, heap is the best data structure that we can use. The step is to convert the input nums array into a heap data structure and then iterate through the heap data structure to figure out the kth largest element. Or in other terms, remove the top k-1 element from the heap data structure to get our output. There are two types of heap. One is the max heap and the other is the mean heap. In the max heap, all of the elements are organized in the descending order, starting with the largest element at the top. While in the mean heap, it's the other way around, where the topmost element is the smallest or the minimum number amongst the input array. As we need to calculate the kth largest element in the input array, the max heap is going to be the most suitable one. Let's start with converting the input array into max heap. Starting with the largest element at the top, which is 7, following that with 6 on the left and 5 on the right. The next number is 5, following that is 4, which will be the legs of 6. After that, the next numbers are 2 3s, which will be the left and the right leg of 5. Now we have two 2's available, which will be the left and the right leg of 5, and then 1 1 under 4. Now to get the kth largest element, we need to remove k-1 element from the heap. So we'll remove the topmost element, which is 7, from the data structure. After removing 7, 6 is the next largest number, which will be moved to the top. As 6 is now the largest element in the array, all of the other elements underneath it will be moved one layer up. So 5 will take its spot, and then 2 under the 5 will take 5 spot. Originally my k value was 4, but now it's decremented by 1, so now k is 3. We'll repeat the same cycle and this time remove the topmost element, which is 6. So all of the other elements underneath 6 will be moved up. So 5 will be taking over its spot, and we need to move up the next big element in that tree, which is 4. After decrementing, the new value of k will be 2. This time we'll remove 5 from the topmost element and move the 5 on the right leg to the top. All of the remaining elements will be moved up. Here's the updated structure. As we have removed 3 elements from the data structure, the topmost element right now is the fourth largest element, which is our output. I hope you were able to understand how we used heap to efficiently solve this problem. With this solution, our time complexity is O of n plus O of k log n. O of n is the time complexity needed to convert the input array into the heap format. And every time we remove an element from the heap, it requires log n time complexity. And we are doing that for k times or k minus 1 times. Hence, that is the other time complexity that needs to be considered. Between these two time complexities, it is difficult to say which one is higher. So hence it's better to leave both of them when we are documenting the time complexity of the solution. And the space complexity is O of n as we are creating or converting the input array into heap data structure for calculation. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is the C# solution. In C#, there is a data structure available called priority queue based on mean heap. It allows us to add elements to the data structure along with its priority. I then start a for loop to add all of the elements into the priority queue data structure. If the size of the data structure is greater than k, then we call the dequeue method on the priority queue. The good part about the priority queue is it only keeps all of the elements which has a higher priority value. So all of the elements that have a lower value will be removed by the dequeue method. So after every turn, the max size of the priority queue will not be greater than k, as we are only keeping the top k elements in the queue and removing the smaller values. After the for loop is complete, we are returning the top element from the priority queue. This code, when submitted on LeetCode, beats nearly 49% of the submissions in terms of runtime and 64% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.